Good morning, good afternoon, good evening to wherever you might be. My name is Zach Harabedian. I'm a product architect with Spot by NetApp. Today we're going to be walking through our hands-on Spot Ocean for Azure workshop. And to get to that place, we're going to go to labs.spot.io/ocean_Azure. And before we get started, there's a couple prerequisites that will help us get through the workshop. So in order to get started, let's dive into our agenda for the day. So we're going to start off setting up our prerequisites. This will consist of making sure that we have access to an existing Azure AKS cluster. We'll make sure that we create a Spot account, Spot by NetApp account, and connect our Azure subscription to that account. And then we'll go through a few different hands-on labs that'll get us exposure into some Ocean-specific features, such as virtual node groups, headrooms, a admission controller, and then we'll get into some more fun labs, such as handling a progressive load and see how Ocean responds to that. All right, so let's jump in. Okay, so my recommendation for the lab is that you open a few different tabs. The first one that we're going to open is the Azure portal. So portal.azure.com. We're going to make sure that we have command line access to our AKS cluster. So this can be done in a few different ways. You can do this locally from your machine, set your kube context, make sure you have access to the cluster, or you can use Azure's Cloud Shell. So we'll quickly go over both of those different options. Next is the Spot organization. So making sure that you sign up for a free Spot by NetApp account, and then you connect your subscription. So we'll navigate through this very quickly. So if you don't already have a Spot account, you can navigate to our console, which is console.spotinst.com, and you'll be able to create a free trial account. And then there'll be different wizards that will help you connect your cloud account into Azure. Okay, once we have our Spot account and all of that is connected, we will navigate to the next page here. So the next page is going to be taking our existing AKS cluster and importing it into the UI. There's a few different ways that this can be done. For the purpose of today's workshop, we're going to be using the UI, but it's good to know that there are different options, such as using Terraform or using our API if you prefer different infrastructure as code options. So once we click into this will help guide us on connecting our account. Since I am going to be driving the workshop, I'm going to just share my screen and navigate this process for you guys. Okay, so let's go ahead and connect our account into Ocean. So just a little bit of quick housekeeping here. I'm in the Azure portal now, so this is portal.azure.com, and I'm going to navigate to the Kubernetes service. And I'll get a general overview about my Kubernetes cluster. And I want to make sure before I get into anything that that I have access to this Kubernetes cluster. So there's a few different ways that we can access our cluster. If you're using something like the Cloud Shell, you can click on this here. And the neat thing about Cloud Shell is it allows you to run all of your commands, right from your web browser. You don't need to set up anything on your local machine. So we will go ahead and provision that. And I'll also show you on the terminal side how we can connect and make sure that we have access to this cluster. So to do this, I'm going to open up my browser here. And I'm going to minimize this for just a second. And I'm going to follow the instructions here. So I'm going to set my account, and I'm going to set my kube context here. And this is confirming that I'm already set with my kube context. And just to test this, I'll do a very simple kubectl get nodes command just to make sure within the correct cluster. Okay, so now that we're squared away on the Azure portal side, let's navigate to the Spot console. Okay, now that we have our AKS cluster squared away and confirmed I have access to that, I'm going to navigate back to the Spot console. And to get here, I'm just navigating to console.spotinst.com. I'm going to log in. Once I log in, I'm going to make sure that I set my account to the subscription that I'm working with. So that I've already done. And on the left-hand side, I'll click on the little hamburger button and make sure that I am in the Ocean tab. So now that we're in the Ocean tab, we'll go ahead and create our first cluster. And then from here, our UI is going to be reading into your existing Azure subscription, and it's going to be looking for resource groups that potentially have an AKS cluster in it. So I know the name of my resource group that I created is Spot Workshop. And once I select that correct resource group, I should see the name of my AKS cluster. And I'll be able to quickly test the cluster permissions. So this is making sure that the permissions that you set up on the on your app registration and attached are giving us the ability to actually launch resources within your subscription, register your nodes to AKS, things like that. So just the basic permissions, we do a quick validation check, and it looks like everything is good to go here. So the next thing I'm going to do is select a node pool to base our VNG templates on. So we'll explain this a little bit further as we go on. But what I'm going to do is I'm going to select my existing node pool that I created here. And this is going to import all the metadata. So really basic information here about the existing node pool that we'll proceed with. Okay, once we verified that the metadata all looks correct from the previous page, next step is to actually install the Ocean controller into our existing AKS cluster. So in order to do that, we provide you a few different options. You can either connect via Helm or connect via kubectl. I'll just use kubectl for the purpose of our demonstration today, but either option will work. So I'm going to generate a programmatic token here. So I'll just call it Spot Workshop, and it will generate a token for me. And then it will also provide me a little bash script below that I can use to connect and deploy the Ocean controller. So I'm in my terminal here, and I'll just create a little script to run. And I'll edit this file. Paste it in here. You'll also notice that the token that we generated before automatically gets imported in. And now I will go ahead and run this command. So looks like everything was successful. So let's quickly review everything that took place. So when we deploy and install the Ocean controller, there's a few different components to it. The first is going to be a config map. That config map essentially tells the Ocean controller which cluster am I, gives it an identity. Along with that, it comes with, it will create a secret. So that way your token that you created is encrypted. And same thing with the Spot account that we're using. So we'll create those two different resources, as well as the Ocean controller deployment itself. So this is a Kubernetes deployment within your cluster. And once we deploy this and install it, it will do a quick ping to our software layer to make sure that we're able to communicate. And once we've done that, we'll do a quick test connectivity and make sure that the controller is able to communicate with our backend. So it looks like everything is good here, and we can proceed to the next step. Okay, the next step is optional, the spot toleration injection. We're going to skip this for now because we actually have a hands-on lab on this part specifically, but I'll quickly review the purpose. So anytime that you're using spot VMs with AKS, AKS requires you to have a matching toleration on the pods themselves that allow it to run on a spot VM. So what we've done is we've created an admission mutating webhook that will dynamically inject this toleration during the pod creation process and eliminate any manual work that you would need to do to add these to your existing YAMLs. So stay tuned for the next part with that. And then the last step here is just a quick review about the Ocean entity that we're about to create. So a lot of this information should look very familiar because this is all going to be, or mostly the metadata that we've been importing from your existing AKS cluster. And we'll go ahead and click create. Okay, so now our AKS cluster is created, and let's navigate back to the labs to determine what the next step should be. And another quick tip I have for using the labs, I'd recommend creating 2 tabs and then opening both the spot console and the labs instructions side by side just to make it a more smooth experience. Okay, so we'll navigate to the next page here, and you'll notice that the theme of our labs is we always start out with a quick overview about the feature that we're going to be performing a hands-on lab with. So the first topic is for virtual node groups. And I like to summarize virtual node groups as like an abstraction from the way you want to run certain workloads from the rest of your cluster. So maybe a good example might be using a virtual node group to run certain workloads on on-demand VMs instead of spot VMs, or you have specific GPU requirements that you want to use. The virtual node groups are a great way to perform that abstraction, and it makes it really easy because we will just utilize your existing like Kubernetes node selector labels and taints and tolerations. So we'll go ahead and click to the next page. So I already went over the high level about what this is all about. So let's skip to creating a VNG. So we've already connected our AKS cluster here. And now we're going to navigate to the virtual node groups tab. Okay. And we are going to go ahead and create a new VNG. And we'll configure this one manually. And the instructions are telling us to specify example 1 as the virtual node group name. And we're going to scroll down to the node selection part of the virtual node group. And we're going to add in a couple different node selector labels. So I'm going to go ahead and click, our type environment is Ocean Workshop. And the example is 1. And now I'm going to go ahead and save this. Okay, so we now have our first virtual node group set up and ready. So now we're going to put this to the test. So once we have our virtual node group set up, we're going to actually start deploying some different YAML files into our AKS cluster. So these YAML files are pre-created for you. You don't need to make any changes to them. And it's entirely up to you for how you want to deploy them. So I'm going to go back to these couple different options here. So if you're using something like the Cloud Shell, you can see that I have my cube context already set, and you can create the files within Cloud Shell and deploy them. Another option that you can do is within the Azure portal itself, I can actually apply a YAML. So if I wanted to create a file locally and upload it, I can do that as well. Or I can just paste in the YAML that was provided. So I'll do a combination of the two just so you can see them. And I'll start with the Azure portal UI here. So within the lab, I'm going to copy this YAML file, and I'm going to go ahead and create that deployment. So it already created the deployment. I see it here, example 1, and I'm seeing that it looks like it's potentially in a pending state. So let's go back to our lab and see what's going on. And I'm being instructed to run a couple commands to understand what's going on with my different pods. So again, a couple different ways that I can do that. I can go into Cloud Shell here, run this kubectl get pods and nodes, and I could see these are the different VMs that were already spun up before I started the lab. And then I also see the pod that I just created as part of this Kubernetes deployment is in a pending state. And we'll give it a couple minutes, but what is going to be happening in the background is we're going to recognize on the Ocean side that, hey, look, we have a pending pod. We need to scale up for that. So now I can see that we're scaling up a node already. And if I were to click into the Ocean logs here, I would understand why. So if I click on the details here, I can see that we're launching a VM, and that is because I have a pending pod. And that pending pod has some resource requests, and it tells me that the name of the VM that we launched, and within a couple minutes, that node will start to register to AKS and register as healthy, and then that pod should get scheduled. So I'll check back in a couple of moments. And okay, so after a couple of moments, I can see that there is a new VM that's been created within my AKS cluster. I can see within my nodes tab here that it belongs to the correct virtual node group. So if I expand this a little bit more, I can see this is all part of example 1. And I can see the resource allocations and a little bit of information about it. So just to confirm this in a different way, I'm going to run the command that the workshop gives me, which is going to tell me within my pods that are running, I see my example 1. And then I also see the name of the node that it's currently running on. So if I were to describe that node, I can do a kubectl describe node. Oops. And I will copy this VM name, and I can see a few different things. So the first thing I want to validate is that the labels that I defined on my virtual node group configuration are indeed part of the node that registers. So here I confirmed that the environment is Ocean Workshop, and this is example 1. And then you'll also notice there's a handful of different Kubernetes labels that are going to be placed onto the VM. We provide a quick link within the workshop if you want to better understand those different labels that automatically get applied. Okay, so this all looks good. I'm happy that this pod was scheduled. And now let's move on to the next part of the workshop. So for that, it looks like we're going to go back to the virtual node group tab. And I'm going to create another virtual node group. And this one looks like it's going to be a little bit different. So I'm going to give it a name of example 2. The environment is Ocean Workshop. And the example is 2. And now we're going to put in a taint on this virtual node group. And we'll give it a value of 2 and no schedule. And now we will go ahead and save this virtual node group. And we're going to have another YAML file that we can now deploy into the cluster. So just to do this one a little bit differently, I'll copy this YAML file and I will just go into Visual Studio for this one and just call it example 2. I'll save it and I'll launch it into my terminal. And I'll just run the command kubectl apply example 2. And I can see that it looks like 2 different deployments were created. So let's jump back into the workshop to understand what's happening. Okay, so let's click back to our lab and understand the file that we just created and deployed into our cluster. So there's 2 different Kubernetes deployments within this file, and they both have the same node selector labels for Ocean Workshop example 2, but the difference is example 2-1 has a matching toleration for the taint that we placed on this virtual node group. So what I would expect is that only the first deployment 2-1 will get scheduled onto a node after Ocean creates a new VM. And this second one, I would suspect, will remain in a pending state. So we already applied this YAML into the cluster. And now let's go ahead and run the kubectl get pods nodes. And it looks like 2-1 is running as we would expect. And 2-2 is still in a pending state. So let's try to understand that, why that might be. So if we run this Kubernetes command, this will give us a little bit more information about the pods in a pending state. So we can see that example 2-2 is in a pending state, and we can do a describe command to understand what is going on with this pod. So as the workshop tells you, we'll run a kubectl describe pod, and it looks like it is failing to be scheduled because there is one node that has an untolerated taint. So that explains it. And none of the existing virtual node groups have a configuration that would satisfy this pod's requirements. So this pod would remain in a pending state until that matching toleration is accepted, or there's some other change that would allow this pod to be scheduled. Okay, so just to summarize the virtual node group lab, we'll click back to Ocean to understand some of the behavior. So within Ocean, we created 2 different virtual node groups. The virtual node groups were set up to, the first one was created with Kubernetes node selector labels that essentially tells any pods with these node selector labels to target this virtual node group. That virtual node group has a set of configurations. So within this configuration, you might be choosing things like what types of VMs I want to use within my allow list, what percentage do I want to run on spot, what do I want to run on demand. things like that. All the flexibility for different configurations can be found in a virtual node group. And then with the second one, the big difference was that we also not only use different node selector labels, but we also implemented node taints. And we were able to see how taints and tolerations affect the ability to schedule these pods onto nodes, and how that specific pod 2-2 remained in a pending state because we couldn't satisfy the requirements there. Okay, so that's it for the virtual node group lab, and we're ready to move on to the next section. So let's go back to our hands-on lab, and that will provide you a quick summary. And now we're ready to jump into Headroom. Okay, so now we're going to get hands-on with Headroom. So Headroom, you can think of it like a spare buffer of capacity within your Ocean cluster. So some use cases as to what Headroom might be used for. You saw in the previous lab that we created some virtual node groups. We deployed a Kubernetes deployment there, and we had to wait a couple of minutes for Ocean to scale up a new node and register to AKS. Headroom, what that does is it allows you to have that compute capacity available. So as soon as your pod gets deployed into the Kubernetes cluster, that buffer of capacity is always available for you to use. So Headroom within Ocean can be configured in a number of different ways. There's the first one is automatic headroom. So this is telling Ocean, I want to keep a 10% buffer of compute within my cluster, and Ocean automatically figures this out for you. So this will maintain the buffer dynamically. So as pods scale up, scale down, we're continuously calculating what this new percentage needs to be to maintain that buffer. So this is like the easiest way to configure it. And then there's also the ability to configure manual headroom within your cluster. So you can say, I always want to maintain X amount of vCPU, X amount of memory, X amount of GPUs. And all of the headroom can be configured on either the cluster level or the virtual node group level. So there's a lot of different possibilities. So let's dig into how it all works. Okay, so within the Headroom lab, it looks like we're going to navigate back to the virtual node group tab here, and we're going to begin to configure another virtual node group. So we'll call this example 3. And environment is Ocean Workshop. And example is 3-1. And if we scroll down to the bottom, it looks like it's going to have us reserve some headroom. So I'll click on the Advanced tab here, and I'm going to reserve 3 units of 100 milli-CPU and 256 megabytes of RAM. And I will go ahead and click Save. And now we're going to create another virtual node group here. And that virtual node group is going to be named example 3-2. Environment is going to be Ocean Workshop. And example is 3-2. And I'll go ahead and click Save. Okay, now that we have our new virtual node groups created, and we specified some headroom for example 3-1, I can see that Ocean has created a new node within this virtual node group. And there's the buffer of CPU and memory created for us. So now let's go ahead and take the supplied YAML file. For this one, I'm going to go into Visual Studio again, and I'm going to go ahead and deploy it. So it looks like everything between these two deployments is exactly the same, with the exception of the node selector labels targeting different virtual node groups. One of them has the CPU and memory buffer from the headroom, and one of them does not. So we'll see what that does for us once we apply it. So both of the deployments have been created. So now let's go back into the lab to figure out what to do next. So once we've deployed that file, I'm going to go ahead and run the provided command. And I can see that example 3-1 pods are all in a running state already. And the 3-2 pods below here are still in a pending state. So this is because we specified some headroom, so we didn't have to wait for that extra buffer of capacity to come into the cluster, whereas the second virtual node group is going to go through the process that the Ocean controller is going to recognize the pending pod, perform a quick calculation on the necessary CPU and memory that we need to scale up within the cluster, and then actually go ahead and launch the compute capacity needed to get the job done. So that's it for the headroom lab. And now we're ready to move on to the next section here. Okay, we are ready for the next lab, which is going to be on the dynamic admission controller. So within Azure Kubernetes Service, there's a little bit of complexity for running workloads on spot VMs instead of regular on-demand VMs. So AKS requires any pods that need to run on spot to have a toleration in them. And this can be a little bit burdensome for your developers, DevOps teams, whoever is maintaining your YAML files that you're deploying to Kubernetes, because you need to manually add this matching toleration to all of your pods if you want to run on spot VMs and save some money. Okay, so how does the dynamic admission controller work? Basically, when you deploy the admission controller, you will configure it to operate in whichever namespaces you tell us. And then as pods come into that into the cluster for those specific namespaces, we will automatically inject a matching toleration that will allow those pods to run on spot VMs. So this is a pretty neat feature within Ocean because it doesn't require any manual intervention from either your DevOps teams or your developers. So out of the box, you'll be able to run all of those workloads on spot VMs. So let's see how it works. So we can go ahead and dig into the lab here. So we're going to go ahead and create this admission controller.yaml. And to do this, I'm going to get back to my Visual Studio. Admission controller.yaml. And I'm going to go ahead and save this and just click back to the labs to make sure I'm just applying this as is. Okay, so let's go ahead and apply this into our cluster. Okay, so now we will run another command just to make sure that this, the admission controller is up and running. So let's clear this out. Okay, so the admission controller is up and running. Okay, let's go ahead and test our new admission controller. So in order to do that, we've provided a few different kubectl commands that we will use to put this to the test. So we'll go ahead and run these. So we're creating a couple namespaces, and we're also we're labeling one of the namespaces as well. Okay, so now this all looks good. And if we run the describe command, we can see the label was successfully applied. Okay, so now let's go ahead and put this to the test. So we provided another YAML here, the deployment. So we'll create a file back in Visual Studio called admission example. I will go ahead and put that in, save it, and go ahead and apply. Okay, so it has created our example here. Okay, now that we've deployed the pod into the cluster, what we can do is we can just run this kubectl command to get the full name of the pod. And now we can do a kubectl describe. And what we can look at here is that the toleration that the admission controller is responsible for adding did successfully add that toleration. So now when we go back to the Ocean console, we can take a look at the VM that this landed on and check the lifecycle. So I can see here the admission example is running on this node. And if I go back to this example one, I can see the lifecycle of this is spot. So you can see the rest of the workloads that we've deployed throughout the workshop before we deployed the admission controller did not have the matching tolerations. So everything up to this point landed on a regular on-demand VM. And it wasn't until we added the matching toleration that we were able to create those spot VMs. So that's it for this lab, and we can move on to the next lab. Okay, so for our final Ocean AKS lab, we're going to be handling a progressive load. So in this workshop, we'll deploy an Apache web service and BusyBox to progressively overload the Apache deployment, trigger scale-ups, and we will watch the Ocean continue to scale up over time. So again, we are provided with an example YAML here. So I'm going to go back to Visual Studio. I'm going to call this autoscale test, paste the file, and I'll go ahead and apply this. Okay, so I can see everything was successfully created. And now let's go back to the lab to see what we should do next. So it looks like everything is going to be targeting the Ocean Workshop Example 1 VNG. And now what we can do is we can configure the horizontal pod autoscaler using the provided command. Okay. And what the horizontal pod autoscaler is responsible for doing is adding replicas based on the configuration that we defined. So we went ahead and defined the configuration for the horizontal pod autoscaler to scale based off of CPU percentage and provided some basic guidelines. So now we can just check the current configuration. Okay, so we can see that it was successfully created. We see the configuration and the targets. So now let's create the BusyBox deployment, and we'll go ahead and apply that. So again, I'm going to go back to Visual Studio and paste this in, and we'll go ahead and apply this. Okay, so that was now created. And now, if we run a subsequent kubectl commands to see what's going on with the BusyBox deployment, we can see that we have several of the pods already in a running state. And what I would expect is if we wait a few more minutes, I'll run this command again, and we will take a look at how many more replicas are added, and we'll check back to see how Ocean is responding and scaling to meet those needs. Okay, so a few minutes have gone by. So let's take a quick look at the running pods that BusyBox is generating. So I can see that there's a lot more replicas that have been spinning up as a result for the Apache service. A number of them are running, a number of them are in a pending state, and this number is going to continue to climb. So if we look back or move on to the next part of the lab, we can take a quick look at the Apache deployment. So I can see 60 of 68 are currently ready. And if we take a quick look at the HPA, we can see that all of that is working as we would expect. And now if we navigate back to Ocean, we can see that there is a lot of scaling going on as a result of the BusyBox. So all of these nodes have, for the example one virtual node group. So if I just filter for example one, I can see that we are continuing to add nodes and continuing to scale up as the load continues to come into the cluster. So you can think of this for your production clusters where the horizontal pod autoscaler is going to be continually adding pods based on the traffic coming into your site or your application, and you need to scale. So as the HPA continues to add pods, Ocean will continue to scale up and be ready for it. So before we get too carried away with the BusyBox, we'll go ahead and clean this up, and we'll let the cluster scale down so we're not paying for unnecessary compute. Okay, so that wraps up our hands-on Ocean AKS lab for today. We'll go ahead and clean up some of our resources so we're not paying for idle compute. So we'll provide you with a few kubectl commands to clean up all the Kubernetes resources that we deployed today. And again, I just wanted to thank everyone for joining today. My name is Zach Karabedian. I'm a product architect with Spot by NetApp. Be sure to check out labs.spot.io for the latest on our DevOps solutions and try them on any cloud that you'd like. If you run into any trouble, don't hesitate to reach out to our awesome support team directly from the Spot console. Thanks and have a great day.